Hello students, in today's class we will discuss about internal nucleophilic substitution reaction, means SNI. Here I stand for internal. Now let's see what is the internal nucleophilic substitution reaction. We have studied in NCERT SN1, SN2, but you have not heard that about SNI, internal nucleophilic substitution reaction. So first of all, you should understand from where this SNI or internal nucleophilic substitution reaction approach comes, correct? So if we react this reactant, means that is a alcohol with SOCl2. SOCl2 means thionyl chloride, then we get that alkyl halide, correct? In this reaction there is a retention of configuration, only retention of configuration product we are getting, only retention of configuration product we are getting. We are not getting inversion of configuration product. So let's summarize what is SN1 and what is SN2 and why this mechanism is different from SN1 and SN2. In SN1 mechanism, we study that this reaction SN1 mechanism occurs in two steps. In first step, formation of carbocation, then nucleophile will attack on carbocation. Because carbocation is a planar geometry, that's why nucleophile can attack forward as well as backward, both type of attack. That's why there is inversion of configuration as well as there is a retention of configuration product. Both product will form in SN1. Means in SN1 mechanism there is carbocation formation, so there is, we can say, retention as well as inversion. Both product can form because carbocation is planar, so your nucleophile can attack from forward side as well as from backward side. So we can say both product is formed in SN1 mechanism. But if we are talking about SN2 mechanism, what is in SN2 mechanism? In SN2 mechanism, there is a backward attack of nucleophile in substrate. Backward attack, there will be backward attack. Due to that backward attack, there is only one product, that is the inversion of configuration occurs. Inversion of configuration means our product will be of inversion of configuration due to backward attack. That is in SN2 mechanism, and SN2 mechanism is a one-step mechanism. So why we are taking another approach? Why from where this SNI come? Let's see. If we are reacting this alcohol with SOCl2, obviously then we will get alkyl halide. But this, in this alkyl halide there is only retention of configuration occur. There is no inversion of configuration occurs. So suppose this reaction occurs through SN1 mechanism. If this reaction occurs through SN1 mechanism, then there should be the product of retention as well as of inversion. But here we are getting only retention product. We are not getting inversion product. So it means this reaction cannot be SN2 mechanism. Again, if we are SN1 mechanism, if we are talking about SN2, in SN2 we are getting only one product, that is the inversion of configuration, and here inversion of configuration is not occurring. It means there it should not be through SN1 as well as it should not be SN2. So mechanism should be something else. So what is the mechanism? That mechanism is SNI. SNI means internal nucleophilic substitution reaction. So let's see what is the internal nucleophilic substitution reaction here. In internal nucleophilic substitution reaction, we can understand, first of all, we are taking our reactant, that is the pH, phenyl ring, CH3, deuterium atom and OH. O has two lone pair of electron. When it reacts with thionyl chloride, so the structure of thionyl chloride is like that, SOCl, Cl. So what happens? The electron of this bond will attract towards Cl because Cl is more electronegative than sulfur atom. So there is partial negative charge, here is partial positive charge. Now what happened? The electron of this bond will attract toward this oxygen atom, because oxygen atom is more electronegative and is polar bond. That's why there is partial negative and there is partial positive charge. Now this bond will break and this bond also break. Now this Cl negative and H positive will come together and they will form HCl. They will form HCl. Now what happened? This oxygen will carry negative charge and this sulfur will carry positive charge and HCl will remove. So we will get like that D, PH, CH3. Then this will attack on the sulfur and we will get O, S, double bond O, and here is Cl and HCl will remove. Now what happened? This Cl negative, this Cl will attract the bond of electron and here partial negative charge, and it is the internal nucleophile. Now this Cl negative is internal nucleophile. It is an internal nucleophile because the Cl negative is present in this molecule. That's why that is internal nucleophile. And this internal nucleophile will attack on this carbon atom. Because it is attacking the carbon atom from same side where OSO2 is attaching, from where leaving group is attaching. That's why there is the retention of configuration. And our product is like that, Cl plus SO2. That is our product. And why there is retention of configuration? Because that internal nucleophile, that is actually chlorosulfide substitute. So alkyl that is this Cl negative will attack on same side where leaving group is attached. That's why we will get the product of retention of configuration. So it happens through some different approach than SN1 and SN2. That's why that is called internal nucleophilic substitution reaction. Next is if we react the same reactant with SnCl2 and if we are taking pyridine as a solvent, then there will be inversion of configuration product we will get. We will get inversion of configuration. So what is the reason behind that? What's pyridine doing? Means we are getting only inversion of configuration product in the presence of pyridine. It means it is clear that here is not SNI reaction, mechanism is not SNI, internal nucleophilic substitution is not occurring here. Here is the mechanism is SN2. Why SN2? Because we are getting only inversion of configuration product. So what is the role of pyridine? What is the role of pyridine? What pyridine is doing? Let's see. Everybody know that pyridine is a good base. So it will make a complex like that. It is a structure of pyridine. Correct. So pyridine is actually, it is a good base. So what happened? It react with HCl. So there is a acid base mechanism. So there is a acid base mechanism and it will produce a good nucleophile Cl negative. It will donate its electron to H positive ion and a complex, that is because it's donating its electron, so here is a positive charge, positive, and Cl negative. That complex is formed in the presence of pyridine. So from this complex it generates a good nucleophile. Good nucleophile Cl negative. Now this Cl negative, what does? the Cl negative attack from backside. The Cl negative, because it has good nucleophile, so it will attack from backward side. That's why there is inversion of configuration occurs in the presence of SOCl2 and pyridine. So we have discussed both reaction SNI, SN1 and SN2, and you should remember SNI is something different from SN1 and SN2, because in SNI only and only retention of configuration product is formed, and if we take pyridine in the presence of SOCl2, then pyridine make a complex, there will be a acid base reaction. That's why there is a generation of a good nucleophile Cl negative, and this good nucleophile Cl negative is capable for backward attack. That's why it will perform backward attack. That's why in the case of pyridine, SN2 mechanism will occur. But if we are not taking pyridine, then there is only SNI, internal nucleophilic substitution occurs. That's why when we are taking pyridine, then there will be inversion of configuration product we will get. And if we are taking only SnCl2, only plain SnCl2 with alcohol, then there will be internal nucleophilic substitution reaction occurs, and we will get the retention of configuration product. So that was the SNI, internal nucleophilic substitution reaction. Thank you.